In this class, I am going to discuss how the stratigraphic and structural interpretation can be made from images of drill cores. I am including structures here. The reason is that when the job is given to a geoscientist for interpretation, he or she may not be asked only for the stratigraphic interpretation. And in fact, the principle goes hand in hand, stratigraphy and structural interpretation. Therefore, I am bringing these two things together. We have to understand how the drilling are done. A drilling can go vertically down or a drilling can go in an inclined direction. How the drill core looks like? It looks like a cylinder, and this cylinder has got circular cross section. If I take a cross section here, it will be circular. We do not have any elliptical cross section known for the drill cores. And from this center, let me draw here, and from this center lying on this circle, if I drop a normal, then this normal is known as the axis of drill core, which I have also drawn over there. The axis of drill core being a line, its attitude will be represented by the two terms plunge and trend, and this attitude includes plunge and trend. Now let us explain how a plane can intersect with a drill core. What will be its manifestation? Let us take a vertical drill core and imagine that it is cut by a horizontal plane. Now this intersection will be circular. This solid line indicates the frontal intersection, whereas this dash line indicates the rear view. Rear means one which is far away from the viewer, and if the viewer goes to the opposite side, then the rear view becomes the frontal view and the frontal view becomes the rear view. One can understand it very well if you take a real cylinder with circular cross section. One can understand it very well by considering that by taking a paper and then rolling it, making it cylinder. Then you can draw this line over here, which is a horizontal plane, and this is circular. From the plan view, this looks like a circular cross section. Now this circular cross section or the circular appearance in the vertical drill core will guarantee that the plane that intersected is horizontal. Let me write down a circular intersection between a vertical drill core and a plane indicates that the plane is horizontal. So this statement is true only when the drill core is vertical. Now we are going to look at the inclined drill core and see how far this concept can be extended there. Now in case of an inclined drilling, the drill core that was picked up will also be inclined with the ground, and imagine a plane has intersected with circular cross section. So I can draw the circle over here. You can take this circle itself or this circle itself or anywhere you can think a circular cross section. Now, naturally from the diagram, as you see, if the drill core is inclined and if the circular cross section is made, the plane that made circular cross section is not horizontal, simply seen from the diagram. Now, so what can we comment if there is circular cross section? Consider the drill core axis which is drawn, and this plane which I can make here by solid black color. I have drawn a plane parallel to this plane or parallel to this plane over here as a line. This is actually a plane parallel to this plane or that plane. This plane is having a dip of theta, that means this plane makes theta angle with an imaginary horizontal plane. And consider the drill core axis which is given by this line is making phi plunge. So, theta and phi are shown. We can actually find out a relation between theta and phi. Now, since the drill core axis is perpendicular to the plane, I can say that in this specific case, the axis of the drill core is the pole of the plane. Which plane? A plane that is making circular intersection on the drill core. So, naturally we can say that the angle between the axis of drill core and that specific plane is 90 degree, which is shown over there. Now, from this diagram what we can say, this horizontal plane and this is also a horizontal plane that was imagined, they are parallel to each other. So, if this angle is theta, this angle is also theta. Now, from the diagram we can clearly see that theta plus phi is equal to 90 degree. An important relation has been obtained. In terms of language, what I can write, theta plus phi is equal to 90 degree is the plunge of the axis of drill core plus dip of the plane is 90 degree. Obviously, there is only one specific value of theta and phi for which they are equal. For theta equal to phi equal to 45 degree, theta and phi are equal. There is only one case when they are 45 degree. That means, if you have done an inclined drilling with plunge of axis of drilling as 45 degree and that makes a circular cross section, that means the plane which intersected the drill core is also having a dip of 45 degree. From this theta plus phi equal to 90 degree, we can see a few obvious interesting relations. Consider phi equal to 90 degree, which means a vertical drilling. Such as this diagram. And if there is a circular cross section, then theta plus phi equal to 90 degree for that specific plane. So, from the relation theta plus phi equal to 90 degree and phi equal to 90 degree, we can say theta equal to 0 degree, which means we are dealing with a horizontal plane. This is obvious and can be seen in this diagram. Now, take another case, phi is equal to 0 degree, which means a horizontal drilling. Such as this case. And if there is a circular cross section made by a plane, so that theta plus phi equal to 90 degree is true, that will mean theta equal to 90 degree, which means that the plane has to be a vertical plane. Such as this. This vertical plane will intersect with a horizontal drill core, making a circular cross section. A circular cross section made on a drill core does not guarantee that the plane of intersection is horizontal. We are going to take now planes of different orientations and how they appear on drill cores as lines of intersection. So far I am talking only as planes. Nowhere I have mentioned what kind of plane it is. It can be any geological plane. So this can be a bedding plane, it can be foliation plane, it can be axial plane of fold, it can be limb of fold. In foliation plane we can think of various types, it can be schistosity, it can be gneiss-osity, this plane can be a fault plane, this plane can be a joint plane or fracture, or this plane can be any other variety of sedimentological cases. So any plane basically, how they intersect of different orientations and how they appear on drill cores as lines of intersection we are going to discuss. So I have drawn a drill core with vertical axis and the drill core is vertical. Now a plane dipping towards me has intersected this drill core. Let me write down, let me draw, this will be the intersection. So as the plane is dipping towards me, the line of intersection between the plane and the drill core, the frontal side is looking like this, a curve, and in the rear side will be. Now if I put a question, a plane dipping opposite to me has intersected the drill core, how will it appear? Let me write down. So this was for that diagram, and how it will intersect the drill core. Say this is a cylindrical drill core and then you are giving a cut in this manner, a plane is cutting. So as you move your hand, you can see my hand is cutting this paper in a curvilinear manner, and then in the other side it goes down, dot 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 line will go down as has been shown here. This is the drawing. You are viewing from this place and you are observing that it is getting a cut. And what about this diagram, the previous one? Here say you are viewing from this place, your eyes are here and a plane has cut in this way. You can see the plane is dipping towards your vision, your direction. So here the plane cuts the cylinder, the dot line will be given, which is given over here, and here the solid line will be drawn. So in this way we have understood how a plane dipping towards me or dipping away from me will look like in a drill core. Let us look at the fourth possibility, that a plane is vertical and the drill core is also vertical, how they will intersect. So, this is how it will look like. This solid line indicates what I can see from the top. This solid line indicates the intersection between the vertical plane and this cylinder. These two dashed line indicates the rear view and the bottom view respectively. So, the vertical plane appears as straight lines and at different surfaces of the drill core. It is a straight line on this horizontal plane and it is a straight line intersection on the curvy planar surface. Here this dashed line indicates the straight line of intersection between the vertical plane and the vertical drill core. So, we are getting 4 lines out, and this line and this line are parallel to each other, and these 2 lines are parallel to each other. We are restricting the discussion on the vertical drill core, and after the explanation is made, the viewer can himself find out the situation dealing with the inclined drill cores. Now, after drilling, one can get the drill cores, and it is not possible all the time for a geoscientist to send the drill core to another geoscientist. The way forward is to take photograph of the drill core and photograph in a manner that the line of intersection is deciphered, and then share that photograph with the other geoscientist. I am going to discuss now the unrolled image of drill cores. Let us try to understand. After the drill core is picked up, it can be kept horizontal on a table, and along its axis we can put some rod. Here we can put a camera for continuous video recording, and this drill core lying on a horizontal table will be allowed to rotate slowly, either clockwise or anti-clockwise, and the camera will record its surface. A video recording will be done. Then that image will be, the image that is captured from the camera will be unrolled or uncoiled to give an idea about the intersection between plane and the drill core. To understand the unrolling and uncoiling of the images, there is a simple way. This case, suppose we have got a vertical drill core on which a plane has intersected as curved line, then we can put a tracing sheet surrounding the drill core. What it means? Say this is a drill core and on its surface a plane has intersected. I can wrap a tracing sheet surrounding it, and with a pencil I can draw those intersecting lines on the tracing sheet. Once that is being done, this tracing sheet can be unrolled or uncoiled, so that the complete geometry of the drill core, which was found on a curvy planar surface, is flattened. It can be called as a kind of projection, and this kind of uncoiled or unrolled tracing sheet will be same as what I am talking in terms of the unrolled or uncoiled images of the drill cores. So, let us look at how a horizontal plane, a plane that dips towards me, a plane that dips opposite to me, and a plane that is vertical will appear in the unrolled or uncoiled images of the drill core. Let us start with the first case. Horizontal plane has intersected and it is a circular one intersection. Obviously, if I open up this image, that circular cross section becomes a straight line, which can readily be demonstrated with a paper. Let us look at this real drill core of marble. In this marble core, I am finding different veins which are going like this, and in the sketch you can easily find out which one can be matched. Now, if I track this one or track this one at the other side or the rear side, what will happen? It has to go up and go in that way, which can be cross checked. For example, here just keep watching, I am rotating it. Here it goes up, interesting, here it got little bit faulted, and then again here it goes down to here. If I track this vein, we can see it goes up, here it gets faulted, and then again here it goes down. So, the purpose of showing this marble drill core is that to demonstrate that there are certain veins dipping towards you in this position, and if you track that vein in the other side or in the rear side, this side, we do find its continuation. In this drill core, we do not see any example of circular cross section. Suppose it were a vertical drill core and I do not see any circular cross section of veins. So, that means this drill core has intersected many planes which are inclined towards you. Now, if we knew the geographic direction, for example, if this is the geographic north direction, then we can say that the veins, the planes are dipping towards north. So, how it will look like? I am taking this case first, and to initiate I can think of 2 points A and B and think that, just for an example, from A towards B is the geographic north direction. So, that means from B towards A is a geographic south direction, and also east and west direction can be understood. Now, once the opening is being done, uncoiling is done, point A is here, point B is here, and again point A comes back. What this straight line indicates? Upon unrolling or uncoiling, the horizontal plane appears like this in the image. So, this is the projection of a horizontal plane in this particular case. So, this is a why point A got repeated, that has to be understood. Say this is point A and this is point B. Now, I am opening. So, once I am opening, as if point A goes to two places, over here and there. So, A, B is here, and then again A. That is why point A is repeated. Now, let us take the case of a plane dipping towards me, and how will it appear if we unroll the image. So, I take here point A and point B, and suppose the opening is done, point A, point B. One can see that here the line actually goes in downward direction. So, from A towards B, basically it goes like this, and then from B towards A, in this dot line the curve moves up. So, it looks like this. Needless to mention that in this case and in this case also, AB distance is equal to the BA distance. By AB distance I mean from here to here. This curve is interesting. We can quickly identify this curve as a sine curve. So, I have drawn here projection of a plane that dips towards me. Now, we can take the case of a plane that dips opposite to me, and how will it appear in its projection in the unrolled or uncoiled image. So, here I take point A and here I take point B. Point A, from A towards B the curve moves up. So, here it goes up, and from B towards A in the rear side actually it goes down. So, it looks like this. So, this is also a sine curve, and this is a case of plane dips opposite to me, and again, and yes, this is a sine curve. Now, in this sine curve we can easily define the amplitude A. Now, we are going to draw the projection for a vertical plane. Here I can take, say, point A over here, and on the rear side point B at that place. So, if I draw now, through A vertical line passes, which is this vertical line, and then comes B, again through that a vertical line passes, which is this dotted line, and over here point A comes back, and here also a vertical line can be drawn. These two vertical lines basically indicate this single vertical line. Here also AB equal to BA distance, and this one is not a sine curve. I hope it is understood. So, what has happened? A plane in this specific projection process has been projected as a line or more than one lines. Plane projected as line. If you recollect the stereographic projection of planes, there also planes are projected as lines. Just to give an example very quickly, not relevant to this work, but I am just doing. Let us say in this north south east west stereographic projection, a plane dips towards east and is having north south strike. So, that is what I have drawn. What happens? The plane is projected as a line. It is a curved line, and if the projection is a straight line such as this passing to the center, then this indicates a vertical plane. At least this similarity can be found between the uncoiled image of drill core and the stereographic projection. In case of stereographic projection, a straight line is the stereographic projection of a vertical plane, and here also, as you see, straight lines are the projection of vertical plane. I repeat, all these things whatever I have said are true when we are dealing with a vertical drill core. If the drill core is inclined, what are the kinds of curves can be produced and how they can be interpreted? In case of stereographic projection of a plane, this peripheral circle indicates a horizontal plane in 3 dimension, whereas a horizontal plane in 3 dimension in this particular case is given by a straight line. So, these are the similarities and dissimilarities with stereographic projection. It is obvious that the principle of stereographic projection and the principle of uncoiling the image, these principles are different.